Hello friends, today we are going to solve problem 2a of exercise 5.2 of the book Elementary Number Theory by David M.Burton, and the problem is if GCD of a comma 35 equals 1, then we have to show that a raised to power 12 is congruent to 1 mod 35. So let's get started with the solution of. Now, because in the question it is given that GCD of a comma 35 equals 1, that means there is nothing common in a and 35. Now, can I say that this thing implies GCD of a comma 7 equals to 1 as well as GCD of a comma 5 equal to 1? Why? Because if we have nothing common in a and 35, then how can we have something common in a and 7 and a and 5? Because 7 and 5 are nothing but the factors of 35. So basically, the above thing clearly implies these two things, right? So can I now say that these two things imply that 7 does not divide a and 5 does not divide a, obviously, because there is nothing common between a number a and 5, which is a prime number. So we can directly say that this prime number must not be dividing this one. So now if we have 7, that means a prime that does not divide a, and 5, again a prime that does not divide a, that means we can apply Fermat's theorem. So above two things respectively implies a raised to 7 minus 1 is congruent to 1 mod 7 and a raised to 5 minus 1 is congruent to 1 under mod 5. Right? Next, this is nothing but a raised to 6 is congruent to 1 mod 7 and a raised to 4 is congruent to 1 mod 5. Now, let's first take only this thing, which is a raised to 6 is congruent to 1 mod 7. Now, we know that in such a congruence, we can raise both sides of the congruence to any integral power. So, raising both sides of this congruence by power 2, we get a raised to 6 raised to 2 is congruent to 1 raised to 2 under mod 7, which is simply nothing but a raised to 12 is congruent to 1 mod 7. This in other terms also means 7 divides a raised to 12 minus 1. I hope you would agree by this step. If not, then a brief explanation to the above step is that this congruence implies a raised to 12 minus 1 is congruent to 0 mod 7, which means that 7 divide this quantity, and that's why I have written the above step. So next, this we have to keep in our minds, okay? Next, if you recall, we also had another congruence along with this one, which was a raised to 4 is congruent to 1 mod 5, right? Now what am I going to do is I'm going to raise both sides of this congruence by power 3. So on the left side we are going to get a raised to 4 raised to 3, which in short will be simply a raised to 12 is congruent to, now 1 raised to any integer will be 1, so this is going to be congruent to 1 under mod 5. Now, which in other terms means 5 divides a raised to 12 minus 1. Now focus on these two things. If 5 divides something, 7 also divides that thing, and 5 and 7 both are two different primes. Both are two different primes. That means that their product will also divide the same quantity. Their product will also divide the same quantity. And what is their product? Their product is nothing but 35 divides a raised to 12 minus 11, and which in other terms means a raised to 12 is going to be congruent to 1 mod 35, right? And this is what we required to prove. I hope it is clear.